All right, we're going to continue on looking at the sliding filament model, look a little bit closer and kind of put some of this stuff together, like the movement of the sarcomere and those bands and lines, and kind of make sure we have it all tied together. So just as a refresher course, this is what we looked at the last video. We talked about the myosin, the thick filament, and the myosin heads, how they have ADP and phosphate attached to them, how we have actin up here, and then actin has three things, these binding sites, tropomyosin, which is covering the binding sites, and the troponin, which holds it in place, and how calcium, which is stored in the sarcoplasmic reticulum, when we have a motor neuron that stimulates the muscle to contract, we have this release of acetylcholine, causes a electrification basically of the sarcolemma, the cell membrane that takes it into the transverse tubules, basically cattle prods the sarcoplasmic reticulums, it releases calcium. Calcium binds to troponin. It causes the tropomyosin to roll off and the binding sites are now exposed. At that point, the myosin heads bind with the binding sites, and in doing so, they have to drop ADP and phosphate, and in doing that, it causes the heads to be pulled towards the midline. And since the myosin heads are now bound to actin, that means all of actin gets pulled towards the midline. And remember, over here we have this Z line that the actin is attached to, which causes the Z line to be pulled into the midline. And since this is happening on both sides, the sarcomere is shortening. Now, when that happens, ADP and phosphate gets turned into ATP, which is the myosin head's favorite thing. So the myosin heads bind to ATP, let go of the binding sites, and in doing so, ATP breaks down into ADP and phosphate, causing the myosin heads to go back to their original position. And as long as calcium is still bound to troponin, the whole cycle starts over. The myosin heads bind to actin, they pull forward, they release the ADP and phosphate turns into ATP, and around we go. All right, just as a refresher. Now, the sign filament model of muscle contraction, or theory, is just that when the sarcomeres shorten, the thick and thin filaments slide past each other. We're going to see how these H zones, the H zone is where the myosin is uncovered, and the I bands where the actin is uncovered, this is going to narrow. The Z lines will move closer together because they're being pulled towards the middle. And then we're going to see that even though the filaments themselves don't change in their own length, there's going to be a look of change because there's going to be more overlap. So the darkest of the bands will be seen much easier. So this is kind of showing this would be considered one little section of the sarcomere. Now again, a sarcomere, as you can see, this is like a little area of a sarcomere. It's got hundreds of them. You can see the little line. This is the M line right there, the middle line. These are the Z lines. This little dark band here, this is where actin and myosin are overlapped. From the dark band to the end of the dark band, that's called an A band. This little zone in here is the H zone, and this little part here is the I band, and it goes from one sarcomere to the other. But as a muscle is stimulated to contract, the sarcomere shortens, and so I have more and more overlap of the actin and myosin. So I'm going to have less free actin and less free myosin, and that's going to make it look different. And that's considered the sliding filament model. Now, again, just going through the order of events, and we'll see I got that same picture coming up. The myosin head attaches to the actin binding sites. This is already after the calcium's been released. This is going to form cross bridges. The cross bridges, when that happens, is going to pull the thin filament towards the center of the sarcomere. And this is because as myosin lets go of ADP and phosphate, it changes that little spot right down here, and it causes the myosin to be pulled forward, which is pulling the actin. ADP and phosphate are released from the myosin, they bind and they turn it into ATP. Now again, we're going to see there's different ways ATP is made. Short incredibly short term, and then long term. Now the linkage between actin and myosin cross bridges break and the ATP splits. Myosin cross bridges goes back to the original position, ready to bind to another, bind it again and start all over. And as long as calcium is in the mix, it will happen. That's exactly what we're talking about here. So this is the start of things. Again, I'm going to have calcium come in. It's going to bind to troponin. As it binds to troponin, it changes shape and it causes tropomyosin to fall off and expose these binding sites. When those binding sites are exposed, the myosin is going to bind to it, and in doing so, it has to let go of the ATP and phosphate it's holding, and in doing that, it changes shape and pulls forward. This is going to pull the whole part of actin towards the middle, actin attached to the Z line, so the sarcomere is going to shorten. When that happens, as the ATP, ADP, and phosphate are released, we're going to find we have ATP. ATP binds to the myosin heads. They let go of the binding sites. And exactly when they do that, the ATP breaks down to ADP and phosphate, and we have the exact same thing that we had when it was at rest. And since calcium is still bound to the troponin, meaning the binding sites are open, it's going to replay this whole thing until it's time to relax. And speaking of relaxing, let's look at how that happens. Now, we said that the key to the start is acetylcholine. Now, the way that this works, as long as acetylcholine is bound in those receptors on the motor end plate, we're going to keep this electrical current going over the muscle fiber. Now, as we want to stop this, what we do, and I'm going to mispronounce this, I call it acetylcholine erase. The true word is acetylcholine esterase. But I kind of like to remember that acetylcholine erase erases acetylcholine, because that's what this does. This chemical is released when we want to quit contracting our muscles. It decomposes acetylcholine and basically pulls them out of the receptors. And those receptors now don't have anything plugged into them, so the power is off. It's almost like imagining a lamp that doesn't have an on and off switch. You just plug it in or pull it out. And as soon as I want to quit that lamp from working, I pull it out of the light socket and the light goes off. And that's kind of what happens with this. I'm going to have a structure called the calcium pump, which is going to take this calcium, remove it from the troponin, and put it back into the sarcoplasmic reticulum. The tropomin-tropomyosin complex goes back to where they were. They're going to cover the binding sites on the actin, and now the myosin heads have nowhere to bind to, and so the muscle fiber starts to relax. Now, there's a lot to what's going to go on in this relaxation. We're going to see it in just a second in the next video and talk about how this affects the strength of muscle contractions in a weird sort of way. But this is the process of it happening. Acetylcholine esterase, or said another way, acetylcholine erase, erases the acetylcholine from the motor end plate and takes it from and decomposes it out of those receptors, causing the whole process to be turned off. The calcium pump's going to take the calcium and put it back into the sarcoplasmic reticulum. The myosin heads now are not going to have a binding site, because once the calcium gets taken off of the troponin, it's going to go back to holding the tropomyosin over the binding site, so there's nothing for it to do, and the muscle will start relaxing. Now remember, in the next video, we're going to look at this, or in a future video, we're going to look at this and how it takes a while for the muscle to get back to its original orientation. And so if you can just in your mind still think about the muscle contracting, and we've increased overlap of the actin and myosin, and slowly it will go back to its original position. And this increased overlap is going to come into play in strengthening muscle contractions in a later video. But I hope this all makes sense. Take care, enjoy your day, and see you in the next video.